Okay, in the last section of our work, we showed you how to do an energy calibration and a full width half maximum or a shape calibration after we did a peak processing and peak locate. And now in order for us to do a quantitative analysis, that means to not only identify the radionuclides but also to calculate the approximate activities of my samples, which is almost the primary location of most applications, I will have to do an efficiency calibration. This is the most complicated part, but it can be easy if we do everything correctly. But the efficiency calibration part, there are two main things that we need to understand. One is that for the efficiency calibration, you need to have a calibration standard source which is going to give you some kind of a reference standard that you are going to use as your reference value. Here we have a disk standard in here that will list the radionuclides that have been here. It is going to be signed by a radiochemist. It will tell you what radionuclides are here, what are the energies, and what are the intensities or the gamma fractions or the emission rates, and also it will tell you what are the actual energies of these radionuclides in the calibration source. In our case, we have one and we are going to use this disk calibration source. In your lab, you probably have one, or if you don't have one, you have to buy one. So the first thing we need to do is, after we have our calibration standard source, we have to get an electronic copy of this certificate in our system, because the computer needs to read this electronic certificate to know what are the actual emission rates which were measured by the radiochemist at the date when this calibration standard source was measured by the radiochemist. So all calibration certificates will not only have the radionuclides present, it will have a very important bit of information in here which is going to tell you what is the assay date or the calibration date. And this date is extremely important, and what we have to understand is that we have to take the spectrum, collect the spectrum in the detector, compare this with the calibration certificate that comes from the radiochemist, compare the two values and calculate the real efficiency of my detector based on the empirical values and the calculated, which means what the values we are getting from the certificate versus what we are actually measured by the detector. So for this, there is something very important I like to mention, which is the date format of the date in the calibration certificate has to match the date format of the computer date and time format. And I say this with particular emphasis for those of us in the United States. Our date format is completely different from the rest of the world. In the United States, we usually go by the month first, then we go to the date, and then we go to the year. In most of the rest of the world, it is usually going to be the day first, month and year. One of the fundamental problems that I have seen that people do when they do this, go through this calibration process and set up this calibration certificate file, that they don't correct the date in this computer and they don't match the date with the date that's in here. That creates a problem in calculating the activity to date, because the computer is trying to read from its today's date, the date in here, and there is a mismatch. So one of the first things we have to do before we do any kind of calibration work is we have to see what is the format of our date. To look at the format of our date, I usually go down here and I look, and I want to match it with the format that is recommended by the manufacturer of the source. The manufacturer of the source which means it is the day first, which is 29th, month, which is March in 2 digits, and then the year in 4 digits. And what's also very important, the separation of this date is through dots, not slashes. And we have to make sure that the date format in our computer matches the date format for this particular software. I'm assuming that the computers used for this application will be dedicated and computers for this particular application. So hopefully you will not have to use this for other applications where they will expect you a different date. So look at the date. I'm going to go in here, and the best way to do the date settings is not from here, is to go to the control panel. So what we do is we go to the start, we go to control panel, and then we go to the settings of date and time here, which is way up here on the top. Once we select the date and time, we have to go to the change date and time. Although we may not have to change the date of today's date, hopefully your computer date is current to today's date, we have to change the calendar settings. And in order to change the calendar settings, we have to, let me cancel out, we have to go to change calendar date, and we have to come here and highlight not the numbers, not the currency, not the time, but the date format. Here the date is correct. Today is Saturday, April 1st, 2017. And I have to make sure that from this list, my format matches the format recommended by the manufacturer of the software, which is in the format of day, month, year in 4 digits separated by dot. So that is going to be day, month, year. But I have to further make some corrections because my year is 4 digits. So I have to hit 44 here, and then I have to manually go in there and put a dot, and my month is going to be 2 digits. So the month will be 2, and then again my day will be also 2 digits, but I have to put dots in here. Remember, day, dot, month, dot, 4 digit year. Day 2 digit obviously because you have up to 30 days. Month 2 digit because you have between 1 and 12, and then year 2017 or 2015 or 2018 4 digits, and is going to be separated by dots. And then instead of hitting reset, I'm going to say apply, and I will say OK, and then again I will apply, and I will say again OK, and OK, and OK, and by now I can see that my date has come to the format. The only way to find out is see whether we have a problem with our calibration standard file that we will create. Once I have the date format set up, the first thing I want to do is to create an electronic version of this certificate, and by doing that I'm going to go to my certificate file editor, which is located in the top right hand corner of my software, which this manufacturer calls it Etalon file editor. Etalon, I believe, is for energy test evaluation report or something. So I'm going to click on the Etalon file, and then you can see that here if you had any previous file that was used in the past, it would show up in here. If it does not show up, then I'm going to go to file, and I'm going to create a new file. So I'm going to go to file, and then I will go to new, and then I will go to edit, and I will say add source set, and usually the source set means the name of the file. So I'm going to say NATS disk 2, and the geometry is something that will specify. My geometry here is a disk. I will specify a disk. The material in this case is not so important because it's a disk source, and then the most important thing is the attestation date, is when this source was measured. This attestation date has to match the format of the date that's in the certificate, and also the format of the date that is read by the computer. Here it says the attestation date is March 20, 2017, which is a fairly recent source. So I will go back into March, and I will select March 20th, 2017, and it says it was done approximately around 12 p.m. in the afternoon. So I'm going to go ahead and select the AM and make it PM, and I will say OK. So now I have actually created a source, a disk source, which was measured on 20th March 2017 at 12 p.m. and the activity units in here are becquerel. The calibration standard source that I purchased earlier, they give the activity sources in microcuries. I had to go to the internet, use a conversion file to convert these activities to becquerels at this date. So I have to use the becquerel measurements here. Now I will also go select this source, go to edit, and I will say add source. The source actually gives you to give it a serial number or something. Here my source is called 0320171. I will create that. Then I will highlight this at the bottom. Make sure you come down here and you select this source that you just created. Then you go to edit and you add a radionuclide. The first radionuclide that I'm going to add is cadmium 109. You can usually go ahead and go from your library here and see cadmium 109. The activity, very important, here is given by the manufacturer to be, if you focus here please, 1.08 microcurie, and that cadmium 109 1.08 microcurie converted to becquerel is 39960. So I will type in 39960 becquerel, and the uncertainty given by the manufacturer here is 5%, I believe. Okay, all the uncertainty here is 5%. If it is not given, you specify that as 5%, which is usually standard. 5%, and I will say OK. Now I will go ahead and again add my second nuclide, which in my case is cobalt 60. So I will go ahead and select cobalt 60 from the list in here, and then again the activity is 0.579 microcurie, which translates to around 21423 becquerels, 21423 becquerels, with an uncertainty of 5%, and I will say OK. And then again my third radionuclide, add nuclide, is going to be my cesium-137 here from my certificate, which is going to be cesium-137. Activity again here is 1.09 microcurie, that translates to around just over 4,000, 40330 becquerels with an uncertainty of 5%. And so now I have created a calibration standard electronic source of my calibration standard source electronic format. So what I have to do is now save it. I have to do a save. Again, it goes up to the default source that we provided with you, a certificate, source certificate. You have to create your own one, so you have to call it, let's say, NATS disk 2 certificate. So now I have created my certificate file, and now I'm going to use this certificate file to conduct an efficiency calibration. I have already measured this source here. I have taken a spectrum. I have calculated the peak activities, and I have now also done an energy and a shape calibration to make sure that I identify the radionuclides at the right positions. And now I have created a certificate file which basically tells me what the values, actual values are for this source measured. And now I have to compare the theoretical values provided by the manufacturer of the source with the actually measured values and create my efficiency curve. If my date and time parameters have set right, I can basically go to processing, and I can now go to an efficiency calibration and do an efficiency calculation. Now the first thing, it tells you to do an efficiency calculation using a file, a default file that we have provided you that has many lines. But that's not the file you're going to use for your detector. You will go in here and you will go to open Etalon files, and hopefully if you go back to the same directory where you saved the file that you just created, which is the NAS disk 2, you will open it, and now it will show up that file in here, which is the 0320-171 disk source, which was measured on March 20th. And if I click on it twice, it will give me this dialog box and tells you that the different geometry parameters in the spectrum and Etalon source files take the geometry from the spectrum or the Etalon file, which means that maybe when I set up my parameters here, I probably specified a point source, and here I set a disk source. So it's telling you, where do you want me to take the geometry from what you specified here or specified in the spectrum. I'm going to say take the thing from the Etalon file. And then it will create some data points in here for the 4 data points that I have used. These 4 data points that I have used. And now I have to do a fit and see if it looks like the characteristic profile of a p-type detector, where you have the highest energy efficiency and around 40 keV, and then it starts to drop off as you go up in higher efficiency. To do that, I have to go to this plus bar in here, and I have to do a fitting. When I do the fitting, it generates a curve, and this curve is going to be based on a polynomial number which I can play with and see if I can get the best fit. This characteristically looks like a profile of a p-type germanium detector. If I go to a higher number, I see it goes crazy, it doesn't look good. If I go to a lower number, it doesn't look that good. So the polynomial order of 2 is the best fitting provided for this particular line. So what I'm going to do is I'm going to accept this calibration, I'm going to save this calibration file. Again, if I see here in my work, my directory structure in here, it tells you LSRM GCD serial number data. It tells you that you want to create a calibration file. I'm going to call it, yes, this is a calibration file for this particular detector, or I can call it something else. Okay, and I can save it, and it will get saved with an extension of .EFFA, which is the default extension for all calibration files. I can save it. I don't need this anymore. And the second thing I can do is I can go in here, which is very important. I can go to actions and I can apply this to the spectrum. Once I apply this to the spectrum, which means that the efficiency is calibrated and is applied to the spectrum that is there, this flashing thing will come up at the bottom. That basically tells you that your radionuclide spectrum file that you have on the screen has been calibrated. So this is a calibrated file right now. I really have no need for this efficiency curve right now. I can close it and I don't need to make any changes. So this is a calibrated file. The best way for me now to test with how good this efficiency calibration file is to go and actually do a nuclide identification and activity calculations and then measure what I have calculated here with what I have in this data sheet in here and see if it's approximately same. It's never going to be exactly the same because there's going to be some error, but if it is within 5 to 6% of what I have measured. To do that, I can go into options, processing, and I can do a calculate activity, all zones, and then it comes up and tells you that these are the activities that I have measured and I have identified these peaks. You can see from here that it has identified my cesium, my cadmium, my cobalt. It has also identified potassium 40, which is present, and then it's telling me that at high end I've also got an unidentified peak, and I think that is the sum peak which is in here. So now I can actually go ahead and do a report by clicking on the report here, and now it comes up and gives you a report file. And actually, to look at the calculations properly, I probably have to go in here, I have to print it, send it to my printer, and then I can, while it's printing, I can calculate. But without printing it, I can see that it found this cesium 137 with an approximate activity of 40,500. And my calibration certificate says that my cesium source has an activity of, in becquerels, 4330, which means I am almost exactly the number that I should find. The activity, calculated activity, is 4500, and the activity that I should have found according to the radiochemist is 4330. What about the cobalt 60? For the cobalt 60, the radiochemist told me the activity should be, according to my activity in becquerels, 21,423. Here I found an activity of 21,200. Very good. It's within 5% error margin. What about the cadmium mono-9? Now again, if you want to find higher accuracy, then you have to count the sample for a longer time. But the cadmium mono-9, probably the error will be a little bigger because I didn't count the sample very long, and it's the peak with the least amount of activity. Here, the radiochemist told me that for cadmium mono-9, my actual activity should be 39,960 becquerel. For cadmium 109, I found 39,200. Almost same. Right, Daniel? Potassium 40, I have no reference line in here, so that really doesn't matter. It's telling me that I found a potassium 40 in here. So now this is my report. I can also change the format of this report, and I am very happy with this calibration right now. So I think that concludes the part of the report in here. The nuclide activity. Now what I can do is I can go in there, I can file this spectrum, save this spectrum, and I can call it calibration 1 disk 0401, which is April 1st 17, and I can save it under my data files. And if I want to frequently load this calibrated spectrum to calibrate my screen, load the calibration, I can also go in there and save this to the database. If I go into save it to the database, if I open my database, I will see this file to be present here. Okay, which is, you can save many things and you can always pull up this from your database. Okay, now one more thing I'm going to show you is how to edit your the report that you generated. Let's say you don't like the report. If you want to edit your report, you go to File, go to Report, and you can actually design your report. Okay, so you can design your report, but in this case we don't want to go to the designing. All I want to change is change the logo. To change the logo in here, what I'm going to do is I'm going to go to File, and I will open the report file that I have used in the past, which is my gamma ENFR report, and I will open it, and I'm going to go here. I'm going to change the logo here. I'm going to highlight the Baltic Scientific logo because this is their report. I'm going to right click and say edit, and then what I will do is I will go to my folder and I will try to find a different file for my report file. I think what we can do right now is go into pictures. I don't have any saved pictures. We can go ahead and find a picture from somewhere else. We can go to our network, or let's say I can go here and I will go to, let's say, Bangladesh Atomic Energy Commission, and when I go to their website, I can take this. If I have a sniping tool, I can actually go and cut their logo, and then I will do File, I do a Save As. I'm going to take that to my C drive under my LSRM work, this particular detector, and I will leave that under BAEC logo as a JPG file, and I will save it. Then I will close all these, and then I'll come back in here, and what I will do right now is go back to Open, and then I will select the subdirectory where I saved it, which happens to be under my here. I will open, and then I will select this, and I will bring the logo here, and now voila, I have changed the logo of the file. If I want to change anything else in here, I can put something else in here, and then I can go in here and I can say Save As, and I will go to my data and I can tool it BAEC, and the report file will always have an extension of .fr3. So we save it, and then we exit. Now if I go ahead and generate the same report, if I go to Options, Processing, do a Calculate Activity, All Zones, I found the thing and I do a report. Again, it's coming up with the old report. Why? Because we really haven't told the program to look for the new report file. In order for me to look for the new report file, I have to go to Configuration Properties, and then I have to go to the File Locations, and where it says where my report file is located in here, in this location, I have to go in there and I have to select my new report, which is BAEC, open, and then I must save it. If you don't save it, the moment you close it, it will go back to the old number. Now if I go in there, Processing, Calculate Activity, All Zones, now I do a report. Now voila, my report is the new report. Okay, now I can print this report and I can send it off as my nuclide activity report, or I can save this electronically, whatever I want. So now that concludes basically the operation of the SpectraLine GP software with loading the configuration parameters, doing an energy calibration, peak locate, peak smoothing, full width half maximum calibration, efficiency calibration, creating a certificate file, doing an efficiency calculations, nuclide identification and activity calculation, reporting and report editing. Thank you very much. Now I'm going to go in there and show you the sequences how to close this. I'll go to properties, I'll go to MCA. I will make sure that my high voltage is off. I don't want to close this with the high voltage off, and then I can simply go in there and exit. Now let's say tomorrow morning I come back in here and I want to turn my system on and start working. I don't have to go back to WinSpec software anymore. If I'm using this particular MCA, I can simply go into a SpectraLine GP. I can load it, and as long as my configuration file is the right configuration file that I have preloaded before, I don't have to do anything. I simply have to go to File, Configuration Properties, go to my MCA. It's already selected. I have to set my high voltage on, and it will tell you what voltage you want. For the sake of thing, I can say 100 volts. Make sure my inhibit signal is the BSI Canberra HPG. Say OK. Alright, the high voltage turns on to 100 volts. You can see that it ramped up and then it went on, and now I can say OK. I can go back. I can open my analyzer. It's pulling up the data from my last count, so I have to go in there and I have to clear my analyzer. And now I can go in there. I can use this green arrow in here to start. This is just a test. I start counting. I will just say for 20 seconds, because the high voltage is not even right. 20 seconds, and now you can see that I'm starting to collect. Obviously it's going to look funny because my high voltage is 100 volts. It should be 1500 volts. Again, I'm showing you how you go back and start back to the same thing. Now you stop it. You can go ahead and clear it. And what you would do every day, now I can turn my high voltage off. Go to 0, close it. What I can do every day, before I count a sample, I can go in here to my file and I can actually load an energy calibration. And I can load the energy calibration that I have used before. So I don't have to recalibrate again. And I can go again to file and I can load full width half maximum calibration. Again, I can load the full width half maximum calibration. And then I can also go here to configuration properties, and I can go in there for identification. Now I can make sure that this is the library that I'm going to use, and for activity calculation I can go and create the detected efficiency file that I have just created before from the data. This is the efficiency file. I can open it, and then I can, if I have any other correction files, Italon Spectra file, library file, I don't think you need this right now, and then you save it. Okay, and then if you go and count any other new spectra, you can start open the analyzer, but you have to turn the high voltage on, and you can basically use the existing calibration to do everything that you need to do from here, this point onwards. So that concludes this test.